So let us start the exercises next. And in this first one, we have to fill in the blanks in some statements, the first of which is this. The volume of a cube of side 1 centimeter is equal to dash cubic meter. So let's see how much this is. So the solution of course is pretty easy. The side length of the cube is given to be 1 centimeter, but you need to have it in meter because then only you can have the volume in cubic meter. So what do you have to do to convert centimeter to meter? Because 100 centimeters equal 1 meter, so you have to divide by 100 because centimeter is a smaller unit and meter is the larger unit. So 10 to the power minus 2 meter equals 1 centimeter. So with that side length expressed in the unit meter, you then find the volume. Because it's a cube, you have to take the cube of that number. And this is the figure that you get, 10 to the power minus 6 cubic meter. But do not forget that we do not have to just simply find the numerical value, we have to also take care of the significant digits, the number of significant digits. The original value was this, 1 centimeter, right? How many significant digits does this have? It has only one significant digit, which is this 1. So this answer should also have one significant digit. Is it really, does it really have one significant digit? Ideally, you should write it like this, 1 times 10 to the power minus 6, because then it's in exponential notation. And this part of the number has only one digit, which is non-zero. And that is why, yes, it has one significant digit. But what if you express it in decimal representation? In decimal representation, it looks like this, 0.000001. After the decimal point, you have 5 zeros followed by 1. That much cubic meter. Does this number also have only one significant digit? Yes, because you recall the rules for determining how many significant digits a number has. One of the rules says that all the non-zero digits will be significant. Besides that, we have 0. So the leading zeros, all these are leading zeros. What are leading zeros? Leading zeros are those zeros that appear before all non-zero digits. They are insignificant. They are not significant. So here also we have only one significant digit. So that's why, yes, this is the answer. Let's see the next one. So the next one is this, B. The surface area of a solid cylinder, you know what a cylinder is, what the shape is, of radius 2.0 centimeter and height 10.0 centimeter is equal to dash square millimeter. So let us first see the geometry. You already know all these things, but still let's see. This is how a cylinder looks. Actually, this is not in general how a cylinder looks. A cylinder need not go straight up like this. It may be slant like this also. And the cross section need not always be a circle. It can be some other shape also. So you draw an arbitrary shape on paper and then you extend that shape like this, keeping it parallel to itself. The surface that you get is in general what we call a cylinder. But if that cross section is a circle and if it goes straight up, if it has been formed by extending that circle, by moving it straight up, then it is a right circular cylinder. That's what we normally mean when we say cylinder. Okay. So then what should be the surface area? The surface area of this surface actually consists of not just this area, but the area of the two cross sections as well. So what will that be? If the cylinder has radius r and height h, in this case radius and height are given, but in general I am saying, then what is the area of this circle? Pi r square, because it's a circle. This circle also has the same area, pi r square. So you add them up and you get 2 pi r square. But what about this area? This area is this length of the circle, that is its circumference, times the height. So the circumference of the circle is 2 pi r and the height is h. So this area is 2 pi r h. So the total surface area is the sum total of these two things. And then you can express it like this, 2 pi r times r plus h. And now we are going to use this to calculate our surface area for this specific cylinder. Okay, so next what we do, we first change the given lengths from centimeter to millimeter, because we want the area in the unit square millimeter. That means we have to multiply each length by 10, because 10 millimeters equal 1 centimeter. So we do just that. So the original radius is 2.0 centimeter, so now it has become 20 millimeter. Similarly, the original height is 10.0 centimeter, now it's 100 millimeter. You may notice one thing, simply 2 is not given, although it looks like it is 2 centimeter, but 2.0. Do you recall that rule which tells us about trailing zeros being significant and also being insignificant depending on what the case is? A trailing zero in a numerical value in an approximate quantity is a zero that comes after all the non-zero digits. This zero is a trailing zero and the only non-zero digit here in this number is 2. So it comes after that, so it's a trailing zero. Trailing zeros are not always significant. They are significant in a number only when there is a decimal point, otherwise not. So that means here we have a decimal point, so this trailing zero is significant. Okay, so that means this number actually has 2 significant figures, not 1. Alright, now if you change the units centimeter to millimeter, you would want to keep the number of significant figures intact, but the value that you are getting is 20. This 0 is also a trailing 0 because it comes after 2, which is the only non-zero digit here. But if you write it like this, then that 0 is not significant because there is no decimal point. If you really want to write it in a way which will convey the message that it also has 2 significant figures, you have to put a decimal point here, only the decimal point, okay, don't write another 0 because then the significant figures will increase in number. But of course, we do not have to do these things. Why? That is because we are going to use these values to calculate the area, and we will decide there finally when we get our answer, there we will come back to the number of significant figures. So let's now calculate the value. Okay, so you use these values in your formula for area, 2 pi times r plus h. So now the unit is square millimeter because the original lengths have been converted into millimeter, and then you calculate the value. Of course, to calculate the value, you would use some approximation for pi, because pi is irrational. You cannot use all of its digits. They are infinite in number and there is no pattern also. 3.141592653, it will keep on coming. So somewhere you have to stop using more digits. So there you have an approximate value. So either you can, if you want, you can use 22 divided by 7, a very crude approximation, or some better approximation. So you do whatever you like to do here, and then finally when you calculate the value, you will get a number. So then how do you decide how many significant digits you have to keep in that number? The rest of it you have to remove. That will be decided by what you have here. This number has how many significant digits? 2, because there is a trailing 0 and there is a decimal point, so that 0 is also significant. The height value has 3 significant figures, and the rule tells you that you have to choose 2 because 2 is the lesser one. That is why you write like this. Actually, the number itself, of course, does not come in exponential notation. It comes in your ordinary decimal notation. There will be a point, some numbers, followed by a decimal point, then some other numbers. So there you will have to keep the first 2 significant digits, which happen to be 1 and 5. And then whatever else is there after that, you have to remove that part. And remember that when you do so, if the first digit of the part that you are removing is greater than 5, then you add 1 to the preceding digit, otherwise not. So those rules you keep in mind. And then finally, whatever you get, when you use the scientific notation to express that, this is what you get. So that is the area value. So you can see that here you have 2 significant figures. This 10 to the power 4, of course, does not have anything to do with the number of significant figures. Both the digits here are non-zero, so 2 significant figures. So that is your area value. The next one is this. A vehicle moving with a speed of 18 km per hour covers dash meters in 1 second. So the speed is given in the unit kilometer per hour. We have to convert it to meter per second. So if we want to convert kilometer to meter, 1 kilometer equals 1000 meters. So you multiply by 1000. And if we want to convert hour into seconds, how many seconds does 1 hour have? 60 times 60 seconds. And when you do that calculation, you get 5. Okay, 5 meter per second. But why are we writing 5.0? That is because the original speed is given like that. There are 2 significant digits. And so we want to keep that 2. That is why, although the answer is 5, but we write 5.0. The moment you write a decimal point and follow that with a 0, this 0 becomes a trailing 0 in an approximate number which has a decimal point. So it becomes significant and gives you 2 significant figures. That, however, itself is not the answer. We want to say how much distance the vehicle covers in meters in 1 second, because this is the speed. So the distance is 5.0 meter. That's what you should write here. Next we have part D. The relative density of lead is 11.3. There is no unit. Relative density is the dimensionless quantity. Its density, that means the actual density of lead, is dash gram per cubic centimeter or dash kilogram per cubic meter. So this is what we know about the quantity relative density. We know that relative density of lead equals density of lead divided by density of water. In general, the relative density of a substance is its density divided by the density of some other reference substance. Usually that reference substance is water, but if we are talking about the relative density of a gas, for example, then the reference substance is dry air, something like that is there, okay. And this relative density originally was known as specific gravity, but this term specific gravity is not being used frequently nowadays. In its place, people means scientists have started calling it relative density. Now it is known that density of water is 1 gram per cubic centimeter. It's an approximate value, okay. Everything here, whatever we do in science, everything is approximate. This is not mathematics. So it's about 1 gram per cubic centimeter. So then from that, what do we get? How do we calculate density of lead? Density of lead would be relative density of lead times density of water. If you are using this unit for density of water, in that unit only you will get density of lead. So relative density of lead is given to be 11.3 and density of water is 1 gram per cubic centimeter. So density of lead in gram per cubic centimeter becomes 11.3, but we want it in kilogram per cubic meter as well. So to convert this value to kilogram per cubic meter, what should we do? We convert gram to kilogram. 1000 grams equal 1 kilogram. So in place of G, if we write kg, we have to divide by 1000 because this is the bigger unit. And then how do you change centimeter to meter? 100 centimeters equal 1 meter. So here also, because we are going from a smaller unit to a larger unit, we divide to keep the balance. That means you divide by 100, so 10 to the power minus 2, but originally it was to the power minus 3, so you keep that, and now the unit is this, kilogram per cubic meter. And then what do you get if you do this calculation? Minus 2 times minus 3 is plus 6, plus 6 minus 3 is plus 3. So 11.3 times 10 cube kilogram per cubic meter is the density of lead.